Good morning, everyone. Now, some of the students requested for the video on how to write the ionic equation. So I'm giving a detailed explanation here. I've already written the examples that we will be taking, and I have also written few examples for your homework. Okay, we'll take one reaction at a time. But one thing common in all these equations, all these equations is that there will be aqueous compound on both the sides of the reaction. As you can see in the first reaction, copper chloride and magnesium chloride are aqueous. Second में hydrochloric acid and calcium chlorides. Third में there are two reactions which are aqueous on the left hand side, silver nitrate, potassium iodide, and right hand side में there is potassium nitrate. And the same thing you will find in everything. So all you need to do in making the ionic equation, is that identify the common ion in the two aqueous solutions on both the sides. That's all you need to do. That ion is the spectator ion. And you just need to remove it. And the remaining part of the equation becomes your ionic equation. It's that simple. It is that simple. Okay. Now let's do this. First of all, we will identify the common ion on both the sides and we will cancel that. So in the first equation, this is ionic, aqueous and aqueous. Isme you can see that chloride ions are common. So I'll simply remove chloride ions. Okay. Here, the two aqueous solutions on both the sides are these. Here also chloride ions are common. Note that there are two chloride ions here, Cl2, but here also there are two chloride ions because there are two HCl. Okay, so you have to cancel. Over here, silver nitrate, potassium iodide, and potassium nitrate. So first we'll see silver nitrate and potassium nitrate में. Silver nitrate, potassium nitrate में nitrate is common. So I will remove nitrate. Potassium iodide, potassium nitrate में से potassium is common. Next three equations. Iron nitrate, sodium hydroxide, sodium nitrate. Iron nitrate, sodium nitrate, nitrate common. Two nitrate common here, two nitrate common here also. Sodium hydroxide, sodium nitrate में से sodium common. Here, the common is between HCl, hydrochloric acid, and sodium chloride. Mein chloride is common. Sodium hydroxide, sodium chloride. Mein sodium is common. Sodium iodide, sodium bromide. Sodium is common. Okay. So we have already identified the spectator ions and we have cancelled them. The next thing that you will do is write the equation without that. Remember that when you write the equation without the cancelled ionic equation, the other substances you must write in their original form. For example, magnesium, the one which is solid, aqueous, and liquid. Aqueous, solid, liquid, and gas. That you'll write as it is. In the aqueous, particularly, you need to be careful that in the copper chloride, for example, if you have cancelled chloride, remember that this copper is not an atom. You'll have to write that as copper ion, Cu2 plus, because it was anyways Cu2 plus, but when it was accompanied with the two chloride ions, the overall formula became neutral. So I did not mention the charge on any ion on this, but copper chloride is an ionic compound and copper ion has the charge there. It's a copper ion, not the copper atom. Okay. Similarly here, when the chloride goes, magnesium ka charge Mg2 plus, you must mention. Similarly here, hydrochloric acid mein se when chloride goes, you need to mention 2H plus. Another care you need to take is that the coefficient. So this 2 here is applicable for hydrogen as well as chlorine. Chloride has gone, but hydrogen is there. So this 2 is for hydrogen also. So don't forget to mention that 2 plus for the 2H plus for the hydrogen. All right. Now we will just write the answer without the spectator ion. And that gives you your ionic equation. So I've already written a duplicate of the equation here. So we'll just make the changes on the duplicate. So here I will simply remove the chloride ion here. But as I mentioned, you must mention the charge on the this thing now. It's Cu2 plus Mg2 plus. This is your ionic equation. Here again in the next one, I will just remove the identified chloride ion here. You can look on the left hand side to see which ions I have identified as chloride ion. And simply 2H plus and calcium is 2 plus. So this is your ionic equation. In the next one, I have to remove nitrate ions as here. So nitrate and from here potassium. And from the right hand side, entire potassium nitrate goes. So I don't need to write that entire. But as we said, ions ka charges you need to write. Whenever you remove the one ion, the other ion ka charge you need to mention. The two ions collectively did not have any charge. So here I will remove nitrate. As we can see on the left hand side, we have crossed the nitrate. And from this, I will remove the sodium, but I will keep that 2 because that 2 is also for hydroxide. So Fe. I will also remove the NaNO3, and that entire I can remove because the entire thing gets cancelled. Now Fe is 2 plus, 2 OH minus gives you FeOH twice. I don't need to keep this plus sign. Over here we had cancelled chloride and the sodium chloride entire compound from. Mention the charges, H plus, OH minus gives you water. Keep the state symbols as they are. In the next one, we cancelled the sodium ions. So sodium cancelled, but 2 I'm keeping because 2 is also for the iodide. Same here, 2 I'm keeping here because 2 also is for bromide. And then mention the charges, 2 iodide and 2 bromide. Remember that this is also aqueous, but I'm not cancelling out this with this iodide because this is iodine molecule and this is iodide ions. Okay. So when iodide was in the sodium iodide, this iodide is an ion, it's an ionic compound, sodium iodide. But this iodine is a molecule. It's two different things. Iodide ion is different. Iodine molecule is different. They have different chemical properties. They have so they are not the same. So you cannot cancel them. So only the common ions, I said, on both the sides, which are aqueous. Common ions, which are aqueous. So in aqueous compounds, if there are common ions, you can cancel them. Molecules, you cannot cancel. Okay, so these are your ionic equations. Okay, now particularly I want you to go through the types of reactions. Uh, this first type of reaction is displacement of metal ion by more reactive metal. So here magnesium is displacing copper. That's a displacement reaction. So displacement reaction may only the one who's being displaced and the one who's displacing it will appear in the equation. So magnesium is displacing copper ions. Okay, the chloride ion here has no role to play, so we removed that. The next one is neutralization. with an insoluble base. It's a neutralization with insoluble base, which is calcium carbonate. Understand that everything will not get cancelled, like the cations and anions both will not get cancelled, because calcium ion is over here is solid and over here is aqueous, so they are not the same. The ion is same, but one is in the solid state, one is in the aqueous state, so you cannot cancel the ions in the two different states. Okay, hence only the chloride gets cancelled. We have another neutralization reaction which we'll see here. Here, this is the neutralization with soluble base, that is alkali. In the alkali, both the cations and anions of the salt will get cancelled. And net reaction always for the alkali, if the acid is reacting with alkali, will be this one. H plus OH minus gives you water. This will be the reaction for all. Even if I change my acid here, suppose if I take nitric acid in the place of hydrochloric acid, but a potassium hydroxide in place of sodium hydroxide, the net reaction ionic equation will be this only. So for any neutralization reaction with acid and alkali, you don't need to look at which acid it is, which alkali it is. This will be the ionic equation. H plus plus OH minus gives you water. That will be the ionic equation. I want you to pay particular attention here. Is precipitation, the two precipitation reactions, precipitation of silver iodide and precipitation of iron to hydroxide. As I have always been saying that precipitation reaction ionic equation is the easiest. Precipitation of silver iodide, suppose I don't have this reaction. I don't have this reaction, but I want to write the precipitation reaction ionic equation. I can write it directly. I just have to write what is the product. Precipitation of silver iodide. Write silver iodide on the right hand side. Precipitation of iron to hydroxide. Write iron to hydroxide on the right hand side and give the state solid because they are insoluble, precipitated. And on the left hand side, you just write the ions that form them. So silver iodide is formed by silver ions and aqueous ions. Iron to hydroxide is formed by iron to ions and hydroxide ions. So just write those ions which form that compound on the left hand side and take care of the number. Like iron 2 hydroxide, FeOH twice, so take 2 hydroxides. And left hand side, both the reactants will have aqueous state. Okay. So in the precipitation reaction, the product is insoluble solid. Reactants may both the ions have to be soluble, which means aqueous. Okay, it's easier to write the ionic equation of a precipitation reaction. Similarly, ionic equation for the neutralization reaction with an alkali is also very easy. Simply write H plus plus OH minus gives you water. That's it. Water should be liquid. H plus and OH minus should be aqueous. Okay. So that's how you write the ionic equation. Hope this has helped you. Now I have also kept few equations here, few questions here for your homework, or you may try these equations and send me the answers, or I will send the answers after some time so you can check the answers yourself. Okay, note that here precipitation of lead iodide may have not given the equation to you because I said that it's easier directly you can write without them. Similarly, barium sulfate is a precipitate. Here also reaction of nitric acid with an alkali, potassium hydroxide. You don't need the main equation, the simple equation, you can directly write the ionic equation. Okay, and these two displacement by more reactive metal to less reactive metal and more reactive halogen displacing less reactive halogen. Okay, so these two equations you need to cancel out the common answer in the aqueous and write the answers. I'll send the marks for this after some time. And I'm sending the screenshot of this also as homework. Okay, so or else you can take the screenshot of this on your screen and solve and send me the answers. Or I will send the marks and you yourself can check the answers. Hope this helped. Thank you.